All right, one thing to know, we are starting topic 9, which is on rates and unit rates. I'm telling you up front today that we are likely going to be taking a topic 9 summative by the end of next week. That's a pretty short time. Here's why. There are not as many standards. Look at your learning targets. There's not as many of them, okay? And most of the work we're going to be doing over the next week or so on rates and unit rates is very, very similar to the work that we did with ratios and proportions. So we're just taking the work we just wrapped up and building on it, but a lot of the concepts are the same. Looking at labels, comparing two things, kind of proportional relationships. Okay, so it's going to go fairly quickly, but we'll be testing, I would say probably next Friday if I were to predict. We've got to get a couple of days farther to make sure that we're on the right track, but I think that it will be a short one. Okay, so this slide up here is the top box on the outside of your notes. So I'm going to have you fill in the blanks, and then we're going to talk through these definitions. I'm going to go ahead to help you here and highlight the words that you need to fill in. Okay, so you are filling in rate, unit rate, and per on those blanks there. On the top box of your notes, do that now. We'll look at that during STAR. All right, so here are two definitions for us to understand. So a rate is just a ratio of two quantities being measured in different units. So really, a rate is really like a ratio that we've already talked about. So here are a couple examples of rates. 4 participants for every 2 teams. So every 2 teams I have, I'm going to have 4 participants. That's a rate because it's comparing 2 different things, participants and teams. Okay. If I were maybe painting my house and I was going to paint 3 rooms, I might need 5 gallons of paint. So 5 gallons for every 3 rooms. That is a rate because it's comparing 2 different things, gallons and rooms. If I work in a restaurant and I make hamburgers maybe and I'm putting tomatoes on them, for every 8 burgers that we have ordered, we need to have 2 tomatoes sliced up. That's a rate because I'm saying how many burgers and how many tomatoes. So that really is no different than the ratio work we looked at with the last topic. So what we're really going to focus on for topic 9 is the idea of a unit rate. And this is what we're going to look at mostly for the next couple of days. So unit rates are rates that have a denominator of 1, and they're often expressed with the word per. So for example, we've got this unit rate here. When we use the slash mark, we've talked about this year, but we pronounce that slash mark when it's written like this as per. So that means 34 miles per gallon. And that's talking about per 1 gallon, okay? 34 miles per gallon means 34 miles per 1 gallon. And we'd be talking about maybe driving a car. I can go 34 miles per 1 gallon of gas that I put in the tank on average. 2 cookies per person. That's 2 cookies per every 1 person. That's a unit rate because it's comparing something to 1 of something else. 62 words per minute. That would be like a rate that we would use when we're talking about maybe reading speed or typing speed, how fast you can keyboard on your computer. I can type 62 words per minute. So on average, I can type 62 words in a minute. Okay? Those are all unit rates because it's not looking at, not only is it comparing 2 different things, but it's comparing one thing to 1 of another thing. Why we use unit rates is because they're good to compare. So for example, if I was looking at maybe gas mileage in cars and I was buying a new car, I might compare, well, what's the miles per gallon in a Toyota and in a Honda and in a Volvo and in all of these different brands of cars? Which car is going to offer me the best gas mileage? And we can figure that out by looking at their unit rates and comparing miles per gallon.
That in a little bit sounded in my head like greener grass, like which is the best deal that you can get.
Yep, yeah. So breaking it down per kind of the unit cost in that case. Good. All right, so how do we find a unit rate? Same thing, this is going to be the second box on that front sheet. So let's fill in the blanks with what I'm highlighting. We're finding a unit rate. And you are filling in what I'm highlighting. And then we'll talk about this as well. So if we look at this, the rate that's given, it says 6 friends have pizza together and the bill is $63. What is the cost per person? So our setup when we're finding a unit rate is going to be something like what it's listed here in the middle. We're going to do our labels and then our known rate and then our unknown rate. This is the exact same setup that we use for proportions. We start by writing out our labels. Then we're going to set up the information that's given, the ratio or rate that's given to us in the problem, and then we're going to turn it into that unit rate, which is the unknown. Okay? So the hint there says that since the question asks for cost per person, think of the word per as kind of that fraction bar that separates our labels. Since it's asking for cost per person, the cost should be first or in the numerator. So when we set this up to solve it, and you can do this maybe underneath or off to the side, cost per person means we're putting cost on top and people on the bottom. That's the labels piece of this. We're setting up those labels. Then it says, since unit rates always have a denominator of 1, we're going to rewrite the rate so that the denominator is 1. So what is the known ratio, the known cost to people ratio that's given in the problem? Jonah?
63.
Good. $63 and 6 people or 6 friends. Very good. So we're going to set that up as cost over people equals 63 over 6. Now, when we're calculating unit rates, here's a nice thing. We're actually going to be able to shortcut, and we don't have to use cross products to solve these. So since we're trying to get a unit rate that has a denominator of 1, in order to get a denominator of 1 here, all we need to do is divide. So in your calculator, you can do 63 divided by 6, because dividing by 6 is going to give us that denominator of 1. And Blake, what does that give you? 10.5 over 1, we would say. So now we just have to interpret what that means. We were looking for the cost per person, so what does that mean?
$10.50 per person.
Good. So the better way to write that would be like that with the label $10.50 and then the slash mark for per person. It's $10.50 per person. And that's our unit rate. Okay. Let's try a couple more. So if you open your notes, you should see a page that looks like this. So again, unit rates are a ratio of a quantity to a value of 1. So what I will tell you right now, one of the most challenging parts of unit rates that I think people struggle the most with is before, when we were doing proportions, we said where we put our labels doesn't really matter. You could put any label on top. When we're looking at rates and unit rates, the order of the labels is going to become more important. And a lot of people, especially in the beginning, have a harder time figuring out, do I put this label on top or do I put the other label on top? So my recommendation to you, and what we're going to do and talk through together, is to kind of read it both ways to yourself and figure out which one seems to make more sense. So I'm going to show you what I mean by that, okay? So the first one says, a movie theater sells 4 bags of popcorn for $16.50. So what you should be asking yourself here is, should I be trying to figure out the cost per bag of popcorn, or should I be trying to figure out how much popcorn per dollar? What makes more sense? Cost per bag of popcorn, or how much popcorn per dollar?
Cost per popcorn bag.
Yeah, I want to break it down into, okay, if I've got 4 bags and I know the total for those 4 bags, I want to know how much does it cost per 1 bag, okay? One hint, and we're going to fill this in on the other page in a second, is anytime it's something that involves cost, put your money up top always. So if it ever has money in it, stick it up top, okay? So we're going to say it's $16.50 up top, and it's 4 bags on the bottom. And then same thing, we can go ahead and turn this into a unit rate just through using division. So we're going to do $16.50 divided by 4. Question or answer? Answer.
I got a little slower. 4
Did you get this to start and then round it? 4.125? Yeah. So if you plug that in your calculator, 1650 divided by 4 is going to give you 4.125. But think about what we're solving for. We're trying to figure out the cost per bag of popcorn. That's not a cost amount. So Griffin, you're right. We're going to have to round that to the hundredths place, which means we're going to round it to 4.13 over 1. Again, you're not going to want to write it when you're writing a unit rate in that final format as a fraction. Instead, interpret it. So right there at the bottom, it says each bag costs. We're just going to fill in $4.13. All right, let's take another one. It takes 3.5 hours to travel 140 miles from city A to B. So again, should we be looking for how many miles per hour or how many hours per mile? Cecilia? Very good. Yeah, and some of them you're going to be like, oh, I've heard that label before, right? Like you've heard miles per hour before, so that makes sense. So let's put miles up top, 140 miles, and 3.5 hours on the bottom, and then you're going to divide.
Keep forgetting.
Miles per hour. So if you're looking at rate, the general rule of thumb for rate is distance over time. So your distance measurement, miles, over time, hours. Grace? 40. So that's 40 over 1, which means it's 40 miles per hour is how we would write that. 40 miles per hour. Yep.
Yeah, yeah.
Yep. All right, last one. This one doesn't involve money or distance, so we're going to have to think about what makes sense here. I can get 2 gallons of ice cream and can make 22 ice cream cones with it. So does it make more sense to figure out how many cones per 1 gallon of ice cream or how many gallons per cone?
How many cones per gallon?
How many cones I can get per gallon of ice cream or how many gallons, so think a gallon of ice cream, a gallon of milk. How many gallons per ice cream cone?
How many ice cream cones you can get out of 1 year?
Yeah, cones per gallon makes more sense here. You're not going to use a full gallon on a cone. So we're going to do cones, 22 cones over 2 gallons. You can probably do this division in your head, I would hope. Oh, check that. 11 over 1. So each gallon makes 11 cones. Good. Can you write cones underneath? Put cones. Yeah, you want to make sure you're in the habit of writing those labels because you will. Mr. Cantor actually asked that first period. He said, do I need to put labels on my work? And I said, depends on if you're trying to pass the test. If you are aiming to get a good grade on your test and show that you know what you're doing, then yes, you're going to want to put labels every time. If you don't have labels, you're going to lose points on every single problem. Oof. All right. I've got some practice with this, but before we do the practice, we've got one last piece. We're not going to finish this whole foldable. There's a lot going on this last page of your foldable, but I actually filled a lot of it in for you. So starting in the top left, I've just got some reminders that unit rates are really just ratios with a denominator of 1. Tells us how much per 1 unit. How it works, we determine which quantity makes sense as a single unit. So again, this is the part that I said is probably going to be the hardest. Trying to figure out which label should I put first, which label should I put second. Once you do that, you're going to write it as ratio and divide the first quantity by the second quantity. Here's where you're going to start filling in. What did we say about money? Always goes on top. Or goes first, however you want to think of that. Money always on top. Then we're going to jump to that middle, reminders. So you're going to think of it as blank per blank. And you're going to write the first item in the numerator.
And the second item in the denominator.
Very good. And the second item in the denominator. And once we have that set up, then we're just going to divide. That's me. So jump to the bottom left, the example says a box of 100 hexagonal floor tiles covers 16 square feet of floor. How much area does a single tile cover? So this one in the question helps us figure out which label should come first. How much area does a single tile cover? So we want to know how much what per what?
Area per tile.
Yeah, area per tile, bless you. So for the setup, we're going to put the quantity in the first blank, belongs in the numerator. This is a repeat of what we just put up there. And the quantity in the second blank belongs in the denominator. So what is our setup? If we look at the numbers and we're trying to figure out area per tile, what should our setup be? Which number is the area? And which,
16 square feet.
yes, square feet is area, so 16 square feet and 100 hexagonal tiles. Don't plug this into your calculator yet. I've got 2 questions for you. First of all, before we do the calculations, if they're hexagonal floor tiles, how many sides does each of those tiles have?
6.
6. A hexagon is a 6-sided shape. Good. Okay, here's why I told you I don't want you to plug it into your calculator yet. I want to know, is there anyone in here, don't shout it out, that can connect what we learned about decimal ratios last week to this fraction here and tell me without even using your calculator what the decimal of 16 over 100 or 16 hundredths would look like. 16 hundredths as a decimal. Anaya?
0.16.
Perfect. Without using your calculator, you're able to do that in your head. Because it's hundredths and it's one of our common place values, you can just turn that into a decimal without even having to plug it in. I think so often we know that we've got a calculator and we rely on it as a crutch that you don't actually think about like, oh, I actually could do that really quick just by using place value and what I know about place
But
value.
it's always good to double check.
It is. You are welcome to plug it into your calculator now and double check. Maybe I made that whole thing up and I just lied to you. It's actually like 0.75.
But you won't get paid if you lie to kids.
I bet they'd still pay me if I lied to kids. I just would have to get caught.
What?
Was I right? Did anyone check it? Fact check?
No.
Thanks. Good. All right. We're going to do our last one in here, and then we're going to do some practice. So what I want you to do with your table groups, the people you're sitting with, Cecilia, you can scoot and join a table if you want. Okay, this question right here that starts with Carl, it says Carl drove 40 miles in 50 minutes and Teresa drove 35 miles in 42 minutes. Who had a higher average speed? Here's what you're doing with your group. You've got to first start by determining which label makes sense coming first if we're looking at speed. Miles per minute or minutes per mile. So you determine that. Then you're going to calculate both of their speeds. So when it's asking you to compare 2 things, you essentially need to find the unit rate for both of those, and then you can figure out who had the higher speed. Okay? Take a couple minutes with your table group, see what you can come up with. Here we go. What made more sense for your label setup? Miles per minute or minutes per mile?
Miles per
Miles
minute.
per minute.
If we're looking at speed, you're going to go distance over time. So miles over minutes. So for Carl, we should have had 40 over 50. What was Carl's miles per minute? Cecilia?
1.25 over.
Ooh, I think you did it backwards. You did 40 divided by 50. Zach?
0.8.
0.8 miles, and then I can put the slash per minute. So 8/10 of a mile per minute. All right, what about Teresa? What's Teresa's setup going to be?
1.2.
What's the setup?
Oh. You do 42 over 35.
Miles over minutes. Yep, 35 over 42, 0.8, oops, that's not an 8, 83 miles per minute. So those are really close, 0.8 or 0.83. If I want to compare, I could write Carl's, as 0.80 and make it go to the hundredths place, and now they're a little bit easier to compare. Who has the faster time, Gus? Teresa goes slightly faster. 0.03 of a mile
Fast.
per minute faster.
Wow.
That's pretty fast.
And also a bunch of other stuff.
Yeah. All right. So again, the big takeaway from this problem, ladies, is that if I've got two different rates, I've got Teresa's rate, I've got Carl's rate, and I'm trying to compare who's faster, who's better, who's whatever, I want to take both of them and turn them into separate unit rates, and then I can compare them. Okay? If I'm looking at just this information, Carl drove 40 miles in 50 minutes, Teresa drove 35 miles in 42 minutes. Can I tell from that information who went faster?
Absolutely not.
No, their numbers are too different that I can't compare. So that's why we use unit rates. When we break it down into comparing each of them per minute, 1 minute, then I've leveled the playing field and I can easily compare them. Okay?